Okay, so more of the answers are up here, so hopefully that's what you did. J, F, A. So now moving to our notes for the day. We're going to be using the quadratic formula, which we're not going to get to yet. We're going to practice what you need to know before we get to the quadratic formula. So this beginning part is what kind of our answers are going to look like. So our answers are going to have radicals involved, and it's going to have this plus or minus again. It's going to have something, or it's going to be over this fraction. So we want to talk about how to simplify things like this. So if you look at the first one, the first thing we can simplify, we have that radical. We have this radical of 2 root 5, or 45. So remember we talked about simplifying the radical. 45 would be 9 times 5, and then 3 times 3. So that radical would really be a 3 on the outside, and then a 5 left in the radical. Since there was already a 2 out there, the numbers will multiply. So this can equal 6 plus or minus 6 root 5 over 6. Now from this part, anytime we have a plus or a minus sign on top of a fraction and the denominator is the same, we can separate it. So this is really saying 6 over 6 plus or minus 6 root 5 over 6. And now we need to simplify this part. We can simplify 6 divided by 6, which is 1. So 1 plus or minus 6 divided by 6, we're simplifying that outside part. So that goes away, and we're left with the square root of 5. And this would be our simplified number, our simplified answer. Okay, so we're going to go to number 2. On number 2, we're going to do the same thing where we can simplify that radical first. So 12 is really 4 times 3, which is 2 times 2. So that radical is going to simplify to be 10 plus or minus. A 2 comes out, but there was already a 3 there, so those multiply. And then 6 root 3, all of that over 4. Now, if we look at that one that we just did, they were all 6s. So that fraction ended up disappearing. This next one isn't so lucky. So what we're going to do, we look at that first term, we look at the number outside of the radical, and we look at the denominator. What is something all 3 of those numbers can be divided by? Hopefully you all just thought 2. That's what we're going to do. It's just simplifying a fraction at this point. So what number could all of them divide by? And that's what we're going to divide it by to simplify our fraction. So we're going to have 5 plus or minus 3 root 3 over 2. Okay. Let's look at the next one. Next one, exact same thing. Simplify the radical. That radical is 75, which is 25 and 3, and that's 5 and 5. So the radical can simplify to be 5, and then plus or minus 5 on the outside, and then square root of 3 left inside, and 10 in the denominator. We're going to do the same thing. It's not all the same number, so we're looking at 1, 2, 3. Those 3 numbers. What could all 3 get divided by? All of them could be divided by 5, which means it's going to turn into 1 plus or minus. 1's going to be outside of our radical, but we don't have to write that, so just a square root of 3. And then over 2. Okay. If we look at the bottom row, so on the bottom row, we got our radical. Hopefully everyone just noticed that that's a perfect square. So this is really going to turn into 3 plus or minus 11 over 4. So we're going to do that problem twice. Once where it's 11 plus 3 over 4, which is 14 over 4, which simplifies to be 7 over 2. And then we're going to do it again where it's 3 minus 11 over 4, which is negative 8 over 4, so negative 2. Okay, so what I want you to do right now is pause the video. I want you to try and simplify the last 2. Okay, so those last 2, the answers are up now. Both of those, the radical couldn't simplify at all, but what was outside of it could simplify. So our answers are going to look like that, and I'm always going to want you to give me the simplified answer. So if we look at the next part, so we're going to start the process of what else we need to have. So what we just practiced was our answer. What we're about to look at is the setup. To have it, to do the quadratic formula, we have to have it in standard form, which is ax squared plus bx plus c and equals 0. So we need to have 0 on that one side. Because we're going to be plugging in the a value, the b value, and the c value for our quadratic formula. So we're going to go through and practice just what's the a value, what's the b value, and what's the c value for all these. So on this first one, our a value is in front of x squared, so 1. B value is in front of our x, so it's 2. And our c value is in the constant, which is -8. On the second one, that's not standard form, so we need to make it into standard form first, and then figure out our a, b, and c. Making that into standard form. We've talked about it. You square this first, so whether you like the area model or whatever, x plus 4 and x plus 4. So this is 2, and then x squared plus 8x plus 16, and then minus 5. Our next step is always distributing that number in front. So 2x squared plus 16x plus 32 minus 5. And then our last step is always combining those last two parts. So 2x squared plus 16x and then plus 27, which means our a value is 2, our b value is 16, and then our c value is 27. So I want you to have you pause the video and go through and answer the others and figure out a, b, and c for the rest. Okay, answers are all up. Go ahead and pause the video if you need to check all your work. Ones that require work, I've written it out. Ones that don't require work are just told the answers. Okay, so once you've checked everything, flip over to the other side. And now we're going to start writing using the quadratic equation to solve. So this big old scary thing is our quadratic formula. That should be an equal sign. Oh, you're just. So when we're using that quadratic formula, it's exactly like it sounds. It's a formula. So all you do is plug in a values, b values, and c values into your equation. So we're going to just get into an example because that's going to make it seem a little bit easier. So if we look at, here's our equation. Our a value is 2. Our b value is a -3, and our c value is a -3. Negative b plus or minus the square root of b squared minus 4ac all over 2a. That is the quadratic formula. We're going to put b in all the spots for b. Notice there's a negative sign in front of that equation. And anytime we're squaring something that is negative, make sure we're using parentheses. So -3 is going in this spot. A is going in here and in the denominator. So 2 and 2. And then C goes in at that last spot. This formula is on your formula chart. All you are doing is plugging numbers in. And now we're going to go through and simplify it. So this part, a negative and a -3, give you a +3. Underneath that radical, it's -3 squared minus 4 times 2 times -3. If you would like to, you are perfectly fine of putting that into your calculator. So negative, or you can do it by hand, but -3 squared would be 9, minus 4 times 2 times -3. So that's 8 times -3, which is a -24. So 9 minus -24, which makes it a +24. So underneath that radical is 33. And in the denominator, 2 times 2, 4. Now, anytime that we have this, so this is our final answer. I know it looks weird, but that's totally fine. We didn't have to do all that work. All we did was plug things into the calculator or plug things into a formula. So now here is a step where if you can simplify, you need to simplify it. So back to what we just did in the very beginning of our notes. Is there something between this 3, 4, and whatever's outside of the radical that you could simplify? Simplify. In this case, we don't have anything, so we're done. Example B is right below it. I know it's kind of a tough squeeze, but we're going to try and figure it out anyway. So, quadratic formula. X equals negative, and then we'll put our B value here, plus or minus the square root of B squared minus 4, our A value and C. All of that is over 2 times A. So we're going to fill in. Here's our A value. So our A goes there and there. B value, which is -9, goes here and here. And then C value, which is -5, goes in there. Now simplify. Next step is always just simplify it. So in the front, we have a negative and -9, so it's a +9 plus or minus square root. Figure out what all that stuff is under the square root. So that'd be 81 minus 8 times -5, which is -40. So 81 minus -40, so 121. All of that is over 4. Hopefully everyone just thought in their head, well, can't we just write 11 instead of 121? Absolutely. So this answer is going to be like numbers without that radical. It's going to be 9 plus or minus 11 over 4. So we are going to do that twice. Once where it's 9 plus 11 over 4, which is 20 over 4, so 5. That's one of our answers. And the other one is 9 minus 11 over 4. 9 minus 11 is -2, so -2 over 4 is -1/2. So there are our answers. Okay. We're going to go down to the guided practice, numbers 1 and 2. So with that quadratic formula, one side has to be 0. And we are not going to write it as decimal. We are going to write it in radical form. One side has to be 0, and then we can plug everything in. So on number 1, we need to move that x part over. So this is really 4x squared minus 3x minus 1 equals 0. So plugging into our formula, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Here's our a value. So put in all the a spots, which is here and here. B is -3, so -3 goes in there, and it goes in here. And our a value is -1, so that goes in there. Step 2, simplify. So simplify anything that we can. That front part, a -3 is a +3. Plus or minus. Everything under that radical becomes 25. And then over 8. Now, since that radical is a perfect square, we can actually simplify this more because this is really 5. So we're going to solve it twice. Once where it's 3 plus 5 over 8. 3 plus 5 is 8, so 8 divided by 8 is 1. That's one answer. And the second one, 3 minus 5 over 8. 3 minus 5 is -2, so -2 divided by 8, that simplifies to be -1/4. Okay. Pause the video. There are 3 other problems. I want you to finish up, 4 other problems. I want you to finish up those 4 other problems and then press play again and check your answers. Okay, so answers are all up there. There are two that are no real solution. We talked about that before with completing the square, but both of those ended up having a negative under the radical. If there's a negative under the radical, then that means there's no real solution. Okay, if you still have some time left in class, come up to my desk and grab the practice problems. It is a class set, so don't mess with it. They'll also be on Canvas later on, so if you want to go back and practice some of those problems on Canvas, that will be provided along with the answers.